Hello, everyone. Thank you very much for joining us today. I'm incredibly excited about today's topic. I saw a version of this talk at London Analytics Engineering Meetup about a month ago and enjoyed it so much that we got Naomi to join us again and do it on this webinar. A little more focused on Looker, but a lot of the stuff is the same, and I'm excited for all of you to see it. Going to be a couple minutes of admin for me to kick off, and then I will hand over to her and we will jump right in. So today we're going to talk about homegrown cost savings in Snowflake using dbt and Looker. I think what the team at Lyst have done in combining metadata from all three of these tools in the same place has allowed them to do some very cool and impressive things. And so I'm looking forward to you all seeing that. Before I hand over, if you haven't joined us before, we do these webinars every other week. They are for the Looker community. They're really about Looker. We at Spectacles, for those of you who aren't familiar with us, provide automated testing solutions for Looker. These webinars are very much not about us. They're kind of our way of bringing the Looker community together, discussing interesting topics and kind of helping people upskill, just learn about interesting things and hopefully enjoy themselves a little bit every other week. So in a couple of weeks, we've got a webinar with the Montreal Analytics team, now the Datatonic team, called Implementing Row-Level Data Security in Looker. We touched on this a couple months ago in a webinar, but this is going to be a much deeper dive into how you do row-level data security, which can be useful for both internal and external use cases using Looker. So I'd invite you to register for that. You can find all of our webinars at spectacles.dev/webinars. You can go and watch our prior ones and sign up for all our future ones. And that one's actually in 4 weeks. So we'll be announcing probably later this week, early next week, what our 1 and 2 weeks will be as well. And I hope you join us there. The final thing I'll say, which a few of you have heard me say already before we kicked off, is we use our Slack community to do all the Q&A for these webinars. We find that it is the best place for people to interact and to keep track of questions and upvote and all that type of stuff. And so if you aren't a member of our Slack community, I'd invite you to head over there. I've just dropped a link in the chat, and the channel is Webinar Homegrown Cost Savings. Head over there, let us know where you're calling from. Would love to see where everyone's joining us from today. And as the presentation is happening, if you have any questions, make sure to drop them there, and we will do our best to answer them at the end of the presentation. That is it from me. So I will now hand over to Naomi and let her tell you all about what they're doing at Lyst. Thanks, everyone.
Amazing. Thank you. I will share my screen and we can begin. Can you see that, Dylan? Awesome. Yep. Amazing. So hi, I'm Naomi. I head up analytics engineering at Lyst. And today I'm excited to talk to you about how we've used dbt and Looker, not just to improve visibility of Snowflake costs in the business, but also to use this to then reduce spend business-wide. So before I get into the presentation, I'm going to tell you a little bit more about Lyst. So for anyone that doesn't know, Lyst is a fashion tech company and premium shopping app. We have over 160 million annual shoppers with products from over 17,000 brands and stores. So we're essentially a place to go to find any fashion item from all the stores that sell them. And within analytics and analytics engineering, our tech stack includes AWS S3, Snowflake with Terraform to manage resources such as users, roles, and warehouses, dbt for transformation, Looker for BI, and Hex for more complex analyses. And then we also have Monte Carlo for data observability. And my team, Analytics Engineering, is responsible for Snowflake, including all of the admin, as well as Looker admin and performance. And we're also responsible for dbt and all of the core business transformation. And then individual teams within the business, including analysts and engineers, can build their own transformation logic in dbt specific to their area. So over the next 20 minutes or so, I'm going to talk you through the metadata that's available in Snowflake, dbt, and Looker, how we use Looker to track Snowflake costs and find our most expensive dbt models, And then finally, how we've used metadata to remove tables in Snowflake that aren't being used anymore by the business, but continue to be built by DBT, and how we've then estimated the cost saving of removing these. So firstly, the metadata and usage data. So as part of our remit in analytics engineering, we want to be sure that we know what's going on in Snowflake, in DBT, and in Looker, and how data is being used across the organization. So we've always tracked some metadata at Lyst, such as the historic queries that are being run, Looker user information, and run history, role grants in Snowflake. So to talk through Snowflake first, Snowflake gives you a lot of this information up to a certain period in the past, such as query history, which gives you the exact query text, the ID, the compute used, the role, additional information like byte scanned, as well as things like access history, which gives you column level direct and indirect access. And so we've had DBT models that take this and then save that history. And then similarly in DBT, it's possible to get DBT metadata, such as every model that you have in your project and its dependencies, and the model's materialization, i.e. whether it's been built as a table or a view. And you can also get DBT Cloud data from DBT Cloud about jobs, such as when they ran, the models that ran, the tests that ran, whether or not they passed or failed. And then finally in Looker, we have for a number of years exported history of what's been run, the explore that's been used, etc. And then what we've done is we've built DBT models on top of this to join that data to get information such as the Looker explore against the query and query history, or the query text related to the column access. And similar to others in the industry, more recently, we've had a focus to see how we can streamline DBT and Snowflake, both to improve performance and efficiency, but also to improve data accessibility by removing bloat in Snowflake and Looker. So the first thing that we needed was to get better visibility of spend in Snowflake. So there are a number of explores that we built in Looker to provide that visibility, not to just us for the org, but also for specific teams to track their spend as well. So for anyone that doesn't know, there are two ways to spend money in Snowflake. The first is compute, and the second is storage. So the first explore that we built was the Snowflake compute cost. And for anyone that's not familiar with Snowflake, Snowflake has what's called warehouses, which are basically compute, and you're charged for whenever a warehouse is active based on the time it's active for and the size of that warehouse. So we created a DBT model to save the historic data from Snowflake's pre-built metering history view, which provides credit usage by hour for every warehouse, as well as clustering costs and snowpipe costs. And for anyone that doesn't know, snowpipe is what we use to get data from S3 into Snowflake. And teams have their own warehouses, which have a predetermined naming convention that we've defined in Terraform. And so we then built a mapping of warehouse name to team, and then joined this in and calculated spend per hour by applying our cost per credit. And then with this table that we built from this DBT pipeline, we then built a Looker Explore for team leads to use, which shows things like, which shows cost over time by team, warehouse size, and also specific warehouse as well. And then the second Explore that we built was our storage Explore. So again, we created a DBT model that saves the history of Snowflake's pre-built storage history view. And the storage history view gives us a daily total storage in terabytes. And then we applied our cost per terabyte and then built an Explore from this table. And this Explore is a lot simpler. It's only got date and storage. Because we're currently not trying to split storage costs by schemas or tables. So we just wanted to know the total cost of storage across Snowflake. And as I mentioned before, DBT is used across the business, and models are built not just by AEs, but also sometimes by analysts and engineering. So we wanted to provide the cost of running DBT in production. I'm going to go into each step in more detail, but the high level overview of building this Explore was to first calculate our cost per query for every query in Snowflake, then ingest our DBT Cloud run data, which is how we run DBT in production, and then join these to create an Explore, which has every DBT Cloud run at node level, i.e. tests, macros, and models, and then estimate the cost of each of these. So how did we actually calculate our cost per query? So because Snowflake charges for the amount of time a warehouse is active, it means that there's no definite cost associated to a query. So to give you an example, you could have a query running that's not using all of that compute. And then if you run another query in parallel, that warehouse might not actually need to be active for much longer. So the cost of that query is dependent on whether or not there's another query running at the same time. Fortunately, select.dev has a blog post with a calculation to estimate this, as well as a DBT package. So we took this calculation and enriched our Snowflake query history table. And when DBT runs queries, it adds metadata as a comment to the end of that query. So we pulled the data from there, such as the node ID, which is the ID of the model for that query, and the invocation ID, which is the specific DBT command that was run for that query to run. And so this gives us every query in Snowflake, plus the cost of that query. And then for any query that was run by DBT, the metadata pulled out as well. And this also happens for any queries run in Looker and Hex. So we also pulled out the metadata from the comments of those and added columns for those queries as well. So when DBT runs a model, it runs multiple queries. So to give you an example, if you have an incremental model, DBT will first build a view or a temporary table with all of the new data, and then run a merge query to merge that data into the existing table. So in order for us to get a full cost estimation for a model when it's run in production, we needed to be able to aggregate all of those queries for that invocation and for that model. Again, fortunately, there's a DBT package that pulls out DBT Cloud data every time there's a run in DBT Cloud. So we use this package and built tables on top of it to get information for every node's execution, such as the start time and end time, whether or not it passed or failed. And then we used the invocation ID and the node ID to then join back to our query history table, and then finally aggregate that to get estimated cost for a model's run. And with all of this, we've then built dashboards for teams to monitor costs and get an idea of where that cost might be coming from. So this is a dummy dashboard as an example, which shows the compute cost, including our most expensive DBT models that team owns. And this has been really helpful in monitoring costs regularly, business-wide, and also for specific teams. And as I'm the person responsible for tracking Snowflake spend across the business, I have a dashboard that's sent to me daily with charts to show historic spend over the year, as well as an estimated annual spend. And then we have this dashboard also sent to analytics engineering every Monday so that the team is aware and we can then discuss if there's anything that we need to look into. And the DBT Explore has become particularly useful day to day because as we create new DBT models or amend existing ones, every team member can now use this Explore to view the cost of a specific DBT pipeline over time, track the cost of any new models that we've built, but also track the cost, the impact of any work done to improve the efficiency of a DBT model. And then within Looker, with the alerting feature, it's really handy because we've been talking about creating alerts for DBT models that are getting particularly expensive, but also alerting if the total cost of all warehouses for a team spikes period over period as well. So the next thing I want to talk to you about is how we remove bloat in DBT and therefore in Snowflake and Looker by finding a way to automate as much as possible, removing tables that aren't needed anymore by the business. And we also wanted to be able to estimate the cost saving of removing these tables and views as well. So last year, to reduce bloat in Snowflake, our version 1 was to automatically remove any tables that haven't been queried by any user in Snowflake. So our solution was to use DBT macros, which are basically functions in DBT, that would be scheduled to run on a weekly basis. So using the Snowflake metadata and account usage, we built a macro that lists all of the tables and views in our database, checks the last query date against that table or view, and if that query date was more than 35 days ago, we move that table to a database that we called our archive database, which is basically a database that only analytics engineering have access to, where we move tables or views for a period of time before we then delete them completely. And then we have a second macro that then runs, checks that archive database, and if a table was created more than 35 days ago in that database, it then drops that table completely. And the reason for this process was in case the table was actually needed, stakeholders have just over a month to let us know, and we don't then need to fully rebuild that table from scratch. And this is particularly useful if that table was being built incrementally, i.e. only new data was being added when it was being updated. And we decided for 35 days as it gives an opportunity for any monthly usage to be captured. And this process to remove any tables that, this process was great because it removes any tables that were either linked to a DBT model that had been, and that DBT model had been deleted, and also removes tables that maybe an analyst or another person in the business had built on the fly and then forgotten to remove. However, this didn't solve the problem of DBT models being built, being run on schedule, but not being queried anymore by the business. Because DBT would be querying that table when it builds it or updates it. And so there'd always be a query date within the last 35 days. So we decided this year to build a solution for this because we knew that there was bigger opportunity here. So this year, we decided to improve on this. To also find tables that are still being queried by DBT because DBT is continuing to update that table, but no one in the business is using it. So the first thing we needed was to get more information about our DBT models. So we used what's called the graph context variable in DBT, which contains every model in your DBT project, including the model name, the model ID, the name of the table that's been built, that will be built in Snowflake, and also any immediate dependencies, i.e. its first degree children models. And it also includes pre-hooks and post-hooks, which are queries that are run before and after that model has been run. And post-hooks are really necessary for us because we have a few tables that are then exported to S3 after that model has been run. So we built a macro that pulls out all of this data and then saves it in a table. And then we used Snowflake's recursive join to then flatten and get every child-parent relationship for every model, including the degrees of separation. And then to ensure that this table is up to date with our current production code, we run this every time a PR is merged in GitHub. So to give you an example, you may have an order staging table, which feeds into your orders table, which in turn feeds into your customers table. So this is the full DAG. And the graph variable will give you the first level children. So it will tell you that stage orders feeds into orders and the orders feeds into customers. And then the recursive join will then loop through every join and allow you to list out the second and so on degrees of separation. So we can see here that stage orders feeds into orders 1 degree of separation, but also feeds into customers 2 degrees of separation. And this is a really simple example, but let's say the DAG was 5 models long. The recursive join would show 1 to 5 degrees of separation for all of the models. So it's basically our DAG in code, and we've called it our lineage table. And it's become a great help for analytics engineering for a number of reasons. The first is reducing the amount of effort when we're seeing what models we need to run. So as an example, let's say we've updated some logic for a table and we need to run the tables that then reference that all the way through to the end of the DAG. So this gives us all of those children models, including whether or not that model is an incremental model or a table. And then we've also got our job tags in here as well. So we can really easily see which models are going to be run and automatically refreshed in a job versus which models we're going to have to rebuild manually ourselves. And we've also decided to save the history of this lineage. So we can also monitor changes to the DAG and changes to configurations of models as well, such as materializations, primary keys, what job that model was being run on. So we have a table with every DBT model and all of its parents and children, plus some additional information. And as I mentioned earlier in the talk, we also have all of our DBT production runs and the estimated cost of each run for a model. So with this, we then built the logic and process to identify and disable unused models. So for a table to be unused, both the table and all of its children can't have been queried. And the reason for this is that a table might not have been queried because it's a staging table, but then it's being used to build a presented table that is used by the business. And we also decided to exclude DBT. We also needed to exclude DBT and analytics engineering tools. And we also decided to exclude analytics engineering completely because we should be building tables that are useful, that the business uses and the business finds useful. Because if we're the only ones querying the table, it's obviously not important for the business. One caveat being our metadata tables. And we decided for 60 days because it encompasses monthly usage, but is also long enough that we're not going to be removing tables that could be useful. So the first step of the process was to build a table that lists out all of the tables that haven't been queried by the business for the last 60 days. And then using that lineage table that we created, checking that also none of its children have been queried for the last 60 days. And then we have an automated Slack message that's sent to our analytics engineering channel to tell us what to disable in DBT. So as you can see in the top right corner, this is what we receive in Slack, which also contains an estimated saving from removing these DBT models. So an AE will then go in, create a DBT PR to disable all of these models. And then the next step is a DBT macro that's run the following Sunday, which uses that DBT lineage table again to check if the table in Snowflake has a DBT model. And because these DBT models will have been disabled, that DBT model will no longer exist. And so then that table will be moved to the archive database. And then the original process from last year will then drop these tables from that archive database after 35 days. And with our DBT cloud data, which has our DBT model cost estimation, we built a dashboard which gives us the estimated saving from removing these models and therefore not running them on schedule anymore. It's really fun to build new DBT models and tables, but it's really easy for spend to creep up over time and also to end up with a cluttered data warehouse. So providing visibility has been great, not only to track our spend, but also to prioritize where to focus on making efficiencies, whether it's specific warehouse or specific DBT models. And this process to regularly spring clean our data warehouse and in turn Looker has been great. Especially given that analysts and engineers can build tables for their areas of the business for specific use cases. It improves data accessibility as data users can find relevant data more easily, but also improves our costs as well. And we've saved nearly 10% of our DBT Cloud Snowflake costs from doing this straight away. There is loads more we can do in this space. So we're really excited to think of new ways to make this process even more intelligent and also use our data to make more efficiencies in Snowflake as well. Thank you for your time. I hope you found it useful and excited to hear what questions people have. Thank you.
Awesome. Well, thank you very, very much. As Naomi said, yeah, we'd love to answer any questions that you guys have. So if you're in the Slack community, make sure to ask any there. There aren't any currently, so I will kick us off with one that I actually asked last time, but when it was given at the meetup, but I enjoyed the answer, so I thought I'd ask it again. So you talked about this graph of like a table that shows all of the interconnected dependencies between the nodes. So I guess more of a comment is the way I'll phrase it, but like you get all of the ones like, oh, if something is one away and two away from a table, you get both of those. You can kind of see like the different ways that stuff could be consolidated. Can you talk a little bit about, I guess, whether that has been useful or how you imagine that might be kind of useful going forward?
Yeah, definitely. So yeah, as you said, if a model is both 1 degree of separation and 2 degrees of separation, we've got it. We've got 2 rows for one for each of those. And to be honest, right now we haven't used it, but we know that it's going to become useful if, for example, we only need to look a certain number of degrees away, but also to figure out if there's potentially some complex tags going on that are unnecessary. There are definitely use cases where you need to do that, but I'd say it's an opportunity for us to review and see if maybe our DBT code could be simplified as well.
You touched on this a little, but what was the process by which you got buy-in for all of this work? I mean, this has obviously been a reasonably large piece of work for the organization and for your team, and you know, takes away to some degree from other stuff that I guess could have been done at a point. What did that process look like as you communicated it to people kind of further up the organization?
Yeah, so cost saving was a priority for us, but obviously we couldn't drop all of our other work to do this. Fortunately, we had some of this already pre-built for other use cases. So to give you an example, the query history we've had for a very long time. The lineage table I actually built for a different project where we were looking to migrate over to some new better DBT code. And so I actually built it for us to be able to really easily see what tables were going to be impacted by that. So a lot of this was already available to us. It was more of a getting it all together and then building that logic or building the logic and getting buy-in on what the time frame was going to be and actually how the process was going to work. I think having the archive database has been a big selling point because stakeholders know that they still have a buffer once it disappears for them. They still have a buffer to get it back. It's not that it disappears completely and we've dropped the table. And yeah, I'd say buy-in actually wasn't too difficult once we explained the process and explained that we have these steps in place that if they still need the data, we can get it back very easily for a period of time.
Makes sense. We've got a bunch of questions that have now come through. One from Simon that says, is any of this open source or could it be at some point? You know, are you thinking about, I think the suggestion is, yeah, lots of this would be useful for people who have, you know, DBT Looker Snowflake's a pretty standard stack these days. You know, have you guys had a conversation about open sourcing it? How much work do you think that would be? How much is like bespoke to your org versus could be used for others?
Yeah, it's a great question. Within analytics engineering, we've definitely had smaller discussions on it. I think it would be a really cool opportunity for us to do that, especially given that it's all in DBT and you can create DBT packages. The cost per query does exist from select.dev, and also DBT cloud data does exist as a DBT package as well. So there are bits of code that you can already take if you wanted to do this. But yeah, we've spoken about it. TBC. I think it would be a great opportunity.
Yeah, I would just echo what you said, which is I think those two DBT packages in particular, if you're on Snowflake and you're on DBT, those two DBT packages are really useful. I know that Select obviously have a product that gives some Snowflake cost stuff. I know some other tools, Select Star, which amazingly is a different tool, also does something similar these days. So if you're watching and you're thinking, oh, I'd love to do this, but I'd rather have it tomorrow and pay money than kind of do it yourself, there's a couple out there that you may be able to look at.
Yeah, and to also use select.dev, they've given us more information than we've built. So yeah, I would definitely recommend them.
Another question from Jake that says, can you give a ballpark of how much you've saved? I know you said kind of 10% of DBT costs. Are you able to kind of talk about the savings elsewhere and just kind of like, I don't know, ballpark figures, things like that?
Yeah, unfortunately, I can't say how much, but it's this process, being able to have this visibility has got us to our target a lot quicker than I think anyone in the business expected. It's been like a huge benefit to us, because especially with the DBT model visibility, we were able to really easily prioritize which DBT models we were going to focus on to then cut or make efficiencies there. And again, with teams as well, we were able to give ownership to those teams to say, you now know your cost, please go and figure out how to reduce that. We're here to help, but you now have visibility of that. And also see which warehouses or which teams are spending the most, that we can work more closely with them. So yeah, I can't unfortunately tell you the percentage, but we reached our target a lot quicker than I think anyone in the business thought we would.
Awesome. Got two questions here from Isaac. First is, what were some of the complexities that you ran into building all of this? So, what were the bits that tripped you up the most, or you found most complex? And the second is, outside of cost, what other, have you learned stuff about your DAG or around your setup, kind of like, other than the cost component, what are other things that this work has I guess informed you about how you as a team, you as a company do analytics? So yeah, the first is kind of, what were the hardest bits? What complexities did you run into? And the other was, what benefits other than costs have you've been able to glean from this?
Yeah, great question. So complexity, the lineage table, I think we didn't know that it was possible. So it was a bit of a kind of trial and error. But once we did it, it was really handy. Again, I didn't know that Snowflake did recursive joins. I wasn't entirely sure. I knew I wanted to create this DAG, but wasn't entirely sure how to. And fortunately, Snowflake gave us the answer to that. When it comes to complexities, it's a great question. I to be honest, I think I think anyone can do this. I think go ahead and do it. There weren't any major complexities to this. In terms of insights that we've gained, it's been interesting to see the cost of incremental models in DBT, or some incremental models in DBT. I think there's a feeling that as soon as you make a model incremental, you're saving money. And actually, we found with one of our models that no matter what we do, we can't make it any cheaper. So I would also, it's a great opportunity to have a look and see whether or not spending all of that time creating a DBT model as incremental is worth it, because you might actually find that that's not the case.
Was there anything about the like underlying data there that made it hard? Was it like it was data that was hard to cluster partition accordingly, or it was just like late arriving stuff? Like, what did that look like in that case?
Yeah, it was data that's hard to cluster, and data that within the micro partitions, there's always, but within most micro partitions, there's always a row being updated. So it was having to scan majority of the table every time it was updated.
Last couple questions here. I think we've probably got time for at least one of these. Question was, how do you know if a business accessed the table in the last N days? Is it done using Snowflake warehouse accessing the table? So yeah, can you just talk a little bit about, I guess, going over again, like how you knew whether a table was being leveraged by the organization or not?
Yeah, so Snowflake has access views, which tell you when a table has been accessed, and also the columns that have been accessed, with a caveat that as soon as you add a star, even if it's count star, Snowflake says that every column has been accessed. So worth taking it with a pinch of salt. But yeah, Snowflake gives you that within a view. So we just use that. We know from our lineage what the Snowflake table name is going to be in case we use any aliases. And then we could just join to see what the last access date was.
And last question we'll do today is kind of, can you just talk a little bit about how you did that mapping of like usage to specific teams? Was it based on just like their groups in Looker? What did that look like in terms of attributing those costs to specific teams?
Yeah, it's a great question. So fortunately for us, we use Terraform to create our warehouses. So within Terraform, we have teams where we've got individuals that are assigned within that team, and that team has roles, a schema, and also warehouses. And those warehouses all have a prefix specific to that team. So we were able to create a mapping of this is the prefix, this is the team, and then really easily assign warehouses and cost to individual teams. So yeah, it's a benefit for us. I don't know if you're doing it in the UI, probably a bit more of a challenge.
Cool. That makes a ton of sense. I'm gonna call it there because we're getting close to time. So yeah, as we wrap up, Naomi, big thank you. I've seen a chunk of this before. I really enjoyed seeing it again. And I so appreciate your time, appreciate you answering all the questions here today. And to everyone attending, as always, appreciate the involvement, all the questions. Doing this for all of you is always made worthwhile by just like seeing the engagement in the Slack, seeing everyone message. So I appreciate all of you joining us today. We will be doing another one in 2 weeks. We'll announce the topic for that in the next coming days. You'll all receive an email about that. And then we'll be doing row level security with the Datatonic module analytics team 4 weeks today. That is all from us. Hopefully we'll see you then. And if there are any topics you'd love to see covered or anything that you might want to present yourself, message us in Slack. Just drop us a note, even if it's like a half-baked idea. Happy to work with you to get your presentation right. These webinars are really for the Looker community, and so yeah, would love to hear from as many of you as possible. So Naomi, final thank you to you. Really appreciate your time.
Thank you so much for this. I've really enjoyed it.
Awesome.
Thanks, everyone.
See everyone soon. Thanks, everyone.